Alright, for section 2.4 you are going to be looking at working with and simplifying imaginary numbers. And so I'll do two examples today. First one, just going to give us two fractions both with i's in the denominator so that neither term is simplified, and they're going to want us to combine them together and simplify. And then the other one we'll do is where we'll solve a quadratic like we normally would, where we'll try to factor or use a quadratic formula if we have to. Alright, so back to the first one. Simplifying this term, 1 plus I over I minus 3 over 4 minus I. I kind of have a choice to make. At some point I need to simplify both of these because having I in the denominator is kind of like having a radical in the denominator. It's not considered to be simplified. So I can simplify these both separately and then combine them together. Or, because I have two fractions and I'm trying to get one answer, I know I'm going to have to get a common denominator and combine these together. So it's up to me which one I want to do first. Do I want to get the common denominator first, or do I want to try to simplify each term first? And like I said, it depends. Sometimes it's easier to get a common denominator, sometimes it's easier to simplify them separately, kind of up to you. So I'm going to simplify them both separately and then get the common denominator. I'll do it both ways and show you that it won't matter which way you do it, you should still get the right answer. Alright, so 1 plus I over I. If I want to simplify just that term, usually you want to multiply by the conjugate of the denominator. So I'm going to multiply by negative I. If you multiply by positive I, it would be fine. You eventually will get the same answer. And if I go ahead and distribute in the numerator, I'm going to get negative I minus I squared over negative I squared. I know the negative I squared here is going to change into 1. This is also going to change into 1. Remember, I squared is negative 1, so it's negative negative 1. So this is actually 1 minus I over 1. So there's what the first one simplifies into. If I look at the second one, it would be minus. Obviously, don't forget about that. That would be important. But if I take 3 over 4 minus I, its conjugate would be 4 plus I, the denominator's conjugate. And if I multiply both numerator and denominator by that, if I go ahead and distribute the 3, I'm going to end up with 12 plus 3i over their conjugates. So when I go to multiply these together or FOIL these together, I don't have to worry about the insides and outsides. I know they're going to cancel. Looks like I get 16 minus I squared, which I know is negative 1, so it's actually 16 plus 1, or it looks like I'm going to have 12 plus 3i over 17. Alright, so now I've got them both simplified. Now I would need to go ahead and get a common denominator with the two. And simple enough for this particular one, it looks like 17 is my least common denominator. So if I multiply by 17 over 17 and again distribute, that's going to give me 17 minus 17i over 17. Here I already have the common denominator. I'm just going to distribute the negative, and that's going to give me negative 12 minus 3i. And now that I have a common denominator, I can just write it all as one fraction. And now, of course, just combine like terms together. So it looks like I have a total of 5 if I look at the whole number part, or the constants. And it looks like I have minus 20i, and I'm dividing by 17. And there would be my answer. Now it's going to ask you to probably write it in a plus bi form, which means it wants you to split them apart and to say it's 5/17 minus 20 over 17 I. Notice that neither one of those fractions simplify. If that ever happens, then I consider this to be just fine. That's technically what they're looking for, but if neither fraction will simplify, then you can go ahead and leave it like that. If one of them will simplify, then go ahead and split them apart and actually do that. So if you're not sure when you should do it, when you shouldn't do it, then just always give this answer and you'll be fine. Alright, now like I said, I simplified them both separately and then got the common denominator. I'm going to go ahead and do the same problem again. This time I'm going to get the common denominator first. So my common denominator looks like I would have to multiply this term by 4 minus I over 4 minus I, and this term by I over I. And so multiplying the numerator out here, it looks like I'm going to get 4. The outsides gives me positive 4i, insides negative 1i, so a total of positive 3i. And then the last gives me negative I squared, which I know is technically plus 1. Over here I just have minus 3i, and then my common denominator, if I multiply it out, is going to give me 4i minus I squared, which I know is plus 1. Alright, and now simplifying, we get lucky here, the 3i's end up canceling, and so this is going to end up being 5 over, and I'm going to rearrange the order because we're used to writing the real number part first, 1 plus 4i. And again, that's not considered simplified because I still have an I in the denominator. So now I need to multiply by the conjugate of the denominator. And now if I distribute the numerator, I end up with 5 minus 20i, not a coincidence, that's what I had over here, it should be that. The denominator, again, they're conjugates, so I don't have to worry about doing the foiling or at least not doing the insides and the outsides. I'm going to end up with 1 minus 16i squared. I know I squared is negative 1, so that changes it to a positive 16. And sure enough, just like we found out on the other way of doing it, it eventually is going to give me the same thing. So it really doesn't matter which way you do it. If you want to get the common denominator first, or whether you want to simplify the terms separately first, it eventually will work out the same. It just kind of depends on what you feel more comfortable doing. One way might be a little quicker, but it's kind of hard to tell until you actually get into it. Alright, so that was the one problem. The second problem we're going to do is just dealing with a quadratic and solving it. Well, I know to solve a quadratic that I can factor. Usually I try to do that first, and then if that doesn't work, I can use the quadratic formula. One thing I notice, if I have one term that's got a decimal and the others don't, or even if they all do, if you want to make it simple, if I don't have a calculator, multiply everything by 10 or however many decimal places you have, then you don't have to worry about decimals. Or if you have one that has a fraction, multiply by the least common denominator and you won't have to worry about the fractions anymore. So I'm going to multiply everything by 10, which will give me 14x squared minus 20x minus 100 equals 0. Again, I don't have any of the decimals to worry about, so it'll probably make it a lot easier in terms of me doing this by hand. Now, one thing I notice, and I tend to look for this, I see that all three of these numbers are even, so I know they have 2 in common, and I'm going to factor that out. Now, you want to get whatever number they have in common out. If you don't get, say I thought they had, well, say they have something bigger than 2 in common. They don't this time, but say they actually did. Once I factor out that 2, I'm going to look at these things again and ask myself, do they have anything in common? Like I look at those and say, oh, they have 5 in common. What about that one? No, that one doesn't. All right, so I've gotten the number that they have in common out, and now I'm basically just going to divide both sides by 2. It'll disappear here. Dividing 0 by 2 is still going to make it 0. And so there is what I'm going to try to set equal to 0 and solve. Now, I normally would try to factor. Multiplying 7 and negative 50 together is going to give me negative 350. That's not the nicest number to have to sit and mess around with to try to find factors of. So of course, if I can't factor, or even if this does factor, I can always use the quadratic formula. And so I'm going to turn to that. Might be a little quicker this time. So I have x is equal to opposite of b, so it's going to be 10, plus or minus the square root of negative 10 squared, b squared, that's just going to give me 100, minus 4 times a, which is 7, times c, which is negative 50. And then that's all over 2a, and a happens to be 7. So now I've got it set up. Now I just have to go through and continue to solve, or simplify. So I've got 10 plus or minus the square root of, yeah, you're probably looking at this and saying that's a big number. There's nothing stopping me from multiplying this out by hand. You know, if I can't do it in my head, and there's no need that you have to be able to do that in your head, multiply it out by hand. I have 2 negatives, so I know it's going to be a positive number eventually. And I know that 4 and 7, if I multiply those two together, gives me 28, and I've got 50. Well, the fact that one of those numbers ends in a 0 is going to make this a little easier. Now, if you don't do this, if you like lattice multiplication, that's fine. Just show your work for it, and I can follow it regardless of which one you're doing. All right, so I've got the 0. Multiply 5 and 8, I know that's 40. Multiply 5 and 2, that's 10. With the 4, looks like it's going to end up being 1,400, or 1,400. And then I'm dividing by 14. So, looks like x is equal to 10, plus or minus the square root of, if I add 100 here, it's going to be 1,500 over 14. And so now I've gotten it simplified down for the most part. All I need to do now is continue to simplify it as far as I can. And so for this one, I can split them apart right now if I want to, or I can try to mess around with that radical. I can see it ends in a 0, so I know 10 goes into it, I know 5 goes into it. I'm going to try to simplify this, so like we learned before, I'm going to break this down into a bunch of prime numbers. Well, I know that 10 and 150 will go into it. No matter what two numbers you pick, eventually you're going to get the same prime numbers. I'm just trying to get these numbers as small as I can, as quickly as I can. 10 breaks down to 2 and 5. Those are both prime. 15 breaks down to 15 and 10. 15 will break down to 5 and 3, and those are both prime. 10 will break down to 5 and 2, and those are both prime. So, if I go to split this, I have x is equal to, it's 10 over 14, which I'll simplify here in a second, plus or minus the square root of 15. Remember, you're looking for groups of 2 because this is an implied 2 sitting here. I've got, let me write this all in one here. I've got 2, 5, 5, 3, 5, 2. It looks like I've got one group of 2 here, which if I think about that, that means it's the square root of 25, so that's actually 5 that can come outside the radical. I also have a group of 2 here. That's the square root of 4, which I know is 2, so the number itself can come outside the radical. Those two don't form a group of 2 of the same thing, so they stay inside the radical. And now just multiply these two numbers together, whatever you took outside, whatever stayed inside, multiply those two together, and it looks like that simplifies to 10 square roots of 15. So this would become 10 square roots of 15 over 14. And now I'll simplify it completely. So x is equal to, simplifying that fraction, I know they both have 2 in common, so it's 5/7 plus or minus. These are both outside the radical, so I can simplify that. The square root of 15 is just left on its own. And this is 5 square roots of 15 over 7, I guess that would be. And that would be my final answer. So no different than anything else that we've solved in terms of quadratic. The numbers were a little bit bigger, but notice not a problem to multiply it out by hand. I don't know why I keep scribbling it out. I guess it's just so that you weren't focused in on it. When you're showing your work on your homework, especially on the test, don't scribble it out because I'm going to need to see this. If you make a mistake and said that this was 2,000, well, I need to see how you got that 2,000 so I can say, okay, yeah, you just made a simple mistake. But overall, make sure that you remember, first of all, they set it equal to 0, but know that you should set it equal to 0. Try to factor if possible. If the number looks too big and you think it's going to take too long to try to find the factors, go to the quadratic formula of this thing because of the radical wouldn't have factored anyway. And then make sure that you simplify all your radicals. You probably would not end up with a number that size, but even though that number was big, the fact that it ended in a couple zeros made this a lot easier for you. Alright, that is the homework help for 2.4. Let me know if you need any other help.